All right, next transformation we're going to talk about is a reflection. All right, and a reflection is just a mirror image across some line of reflection. And so in this case, I'm going to take triangle ABC and reflect it across the line of reflection, or in this case, the line segment. I'll make it a line. Why not? Here, now it's a line. Okay, reflect it across line YZ. Okay, so let's reflect, and we're going to make triangle A prime B prime C prime. All right, so what we're going to do is we're going to reflect each point across this line of symmetry, which it happens to be a y line, an x equals something, so y is up and down, right? The line is up and down when x is something. That's confusing to some people. When y is equal to something, you're talking about a line that goes right and left, and when x is seen, maybe I should write that down. So if x equals some number, the line does this. When y equals some number, the line does that. That's something nice to know. Okay, so that's a little bit of algebra review. But we're reflecting across this up and down x equals something line. Okay, it doesn't really matter, because what we do need to know is that look at how far it is from the line, each point. It is from the line, and it's going to be the same distance from that line, but on the other side, and on the same vertical position, right? What I mean is it's got to be on the same line here. All right, so let's start with A. A is 1, 2, 3, 4, 5, 6, 7, 8 away from this line of reflection. So it's going to be 8 away from this side. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is going to be, I should make this a different color. I'll make that purple. Make that A prime. Okay, now B, how far is B from the line? It's 1, 2, 3, 4, 5, 6. So it's going to be 6 on this side. 1, 2, 3, 4, 5, 6. So this is B prime. All right, and then C is 2 away from the line of symmetry. So it's going to be 2 away on the same y value as C prime. Okay, and connect all the dots, and you're going to see that it is a mirror image of the original one. As long as my lines are close enough, it'll look all right. And there you go. Let's see, let's double check. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yep. 1, 2, 3. 1, 2, 3. And then 2 over and 2 over. Yep, so that looks like it's a good reflection. It looks a little different. Probably just a little optical illusion based upon where I put the variables. Maybe I'll move this one up here. Not the variables, the point letters. Maybe that looks better. Okay, but now what can we say about angle A? So this is angle A, and this is the line segment opposite of angle A. So this is BC, right? I can say that angle A is congruent to angle A prime, and line segment BC is congruent to line segment B prime C prime. All right, so that's how I show that there. Let's see if I can color code this. Right, so angle A is congruent to angle A prime, and line segment BC is congruent to line segment B prime C prime. I'm gonna color code it that way this time. Okay, now moving on to, how about orange? Okay, let's go to angle B. We're gonna make that a double angle. And its opposite line segment will have a double slash. Okay, and over here, angle B is congruent to angle B prime, and C prime to A prime is congruent to A to C. So I'll just say that angle B is congruent to angle B prime, and angle CA is congruent to line segment CA. Line segment CA is congruent to line segment C prime A prime. That's orange. Okay, and then let's go to about green this time. I don't know how well green shows up. All right, but this is going to be my third angle that I named. Now it doesn't have, you could name any one of these the same as long as the pattern at the opposite, especially for triangles, that the opposite line segments have the same number of arcs and slashes and therefore and so on and so forth. All right, so I'm gonna call this angle C, which is congruent to angle C prime, and angle A, or line segment AB, is congruent to A prime B prime. All right, so that is a reflection, and I hope that that makes sense. Now, if I were to reflect this one across that way, I guess I could do that. I'm only a couple minutes in. Let me extend line Z to give myself some more room. Let's reflect. This is Z. Let's reflect it across line XY, or no, let's do this. Let's call this x equals 0. Okay, that's what it is. That's the y axis, or excuse me, y equals 0. I did it. I made that same mistake. Y equals 0. All right, it's my left and right. So I'm gonna reflect ABC, triangle ABC, across line y equals 0 to make triangle DCE. Make it blue. Triangle DEF. Okay, so now I got to do the same thing here. I'll start with A. It's 3 away, so I'm going to go 1, 2, 3, and there is D prime. A lines up with, you can't see what I'm doing. Okay, A lines up with D. Okay, now B is going to be E, so it's going to be 1, 2, 3, 4, 5, 6. So it's going to be 1, 2, 3, 4, 5, 6 right on my X. And this is going to be line B, or this is going to be E. All right, and then C is 2 away, so it's 1, 2. And that C turns into F. That's going to be like that. Okay, so now I connect all those lines like this. It's a little messy because I didn't give myself enough gap on the bottom, but I think you can still get the point. And there you go. There's a reflection across a horizontal line. Right, and let's go ahead and mark our congruent angles. This one is congruent. This is congruent to that. Those are my congruent marks. Moving on to orange. This is the same as this one. Those are congruent. And then my green one is F, like there to there. Okay, so it gets you in that pattern of matching opposite, especially with triangles. It works really well with triangles. So get in the in the habit of marking your congruencies like that. All right, hope that makes sense. That was just over 10 minutes. If you have any questions, please let me know.